Hi everyone, I hope you're well. Hope you had a great Christmas and Happy New Year. I'm trying to think because your tutor group. Oh yeah, just looking here at Miss Fennessy's challenge that she's put up. So it'd be great if everybody could get involved and we could try and win. I'm doing a good bit of running, so I should be able to put up a few kilometres every week. So it's just whatever you walk, if you can record the kilometres, or if you're into running or whatever, record the kilometres and put them up, and then we get like a class total, and the class that does the best, there'll be a prize for the next 3 weeks. So yeah, if you get involved in that, that'd be cool. With regard to science, we are moving on here to chapter 23. So for those of you in my maths class, it's going to be the same deal in science. This video will be emailed to you on Tuesday mornings and Friday mornings, because that's when we normally have science. The emails are sending at 9 a.m. So you have them, and you can do them when science is supposed to be on or whenever you choose to do them. But you'll get an email it will come at 9 a.m. So same as last year, you'll listen to the video, take down any notes that are important, any homework that you're going to do will be put into your folder under homework. Okay, and then what I want you to do is I want you to match the heading on your homework to whatever I call the video. So this one is going to be chapter 23 part 1. Okay, so I don't think there's going to be any homework on this today anyway, but that's how it's generally going to go. So whatever I call the video, in your homework section of your own notebook, you will create a page called chapter 23 part 1, and that's where you'll upload your homework. You can do it directly onto the iPad if you have a stylus, or else, like you've been doing, do it into your copy, take a picture and upload it. Okay, so that's how we'll do homework. I'll check the homework then. It'll be due at 9 a.m. the following class. So if I gave you homework today, which I won't, but if I gave you homework today, it would be due Friday at 9 a.m. The homework I give you on Friday will be due Tuesday at 9 a.m. Okay, so that's generally how it's going to work. Timing wise, I'm aiming for, like you'd normally have an hour in class plus your homework. So I'm kind of aiming for around that. Okay, you really shouldn't be spending longer than about an hour and 15 minutes or so between the video, the notes, and doing your homework. That's about what you should be doing. So the hour that you would have spent in class plus the 15-20 minutes you'd spend on your homework. Okay, so that's kind of what I'm gauging it at. If you're going way over that kind of time, you need to let me know because we need to tweak it a bit. I'm obviously going off what I would complete in class, and that's me pushing you to take notes and stuff, so I don't know how efficiently you work at home. Okay, so the video will come at 9 a.m. on the day you would normally have science. You watch the video and pausing it whenever you need to take down notes. That's a nice, I suppose, advantage of this, that you can shut me up and take down your notes. For every class, I'm going to open up, a collaboration page. So this one is going to be chapter 23, part 1, questions. Okay, so if at any point during it you have any questions, you can just type your questions in here and then I'll answer them. Okay, so I'll do that for every class, and if you have any questions, throw them in here. If they're kind of easy enough to answer, I'll answer them. Like, I'll just type an answer back. If I feel it requires kind of a decent amount of explanation, I'll record another video as an explanation. Okay, so I'm trying to add this because I sort of feel like this is what was missing last year, that we really didn't have a good outlet to ask questions. So And this will also give me a really good indicator as to whether we need to do a live lesson. So what I'm thinking is I deliver a lesson if there's, a couple of questions that are all reasonable and I can answer them, no problem. If for whatever reason the material just hasn't landed, so I'm explaining it but you're clearly not picking it up correctly, and I know that based on your questions, then maybe we need to have a live lesson. Okay, so if you have any questions, if anything pops into your mind as you're listening to the video, maybe pause it, go into the collaboration space and write down your question. Okay, is there anything else? I told you how we're going to submit homework. I think that's it. So I think we might get started. Okay, so in black here is the this is from the junior cycle specifications. Okay, it links with this specification up here, which is called Earth and Space 4, Earth, Moon, and Sun. So we're still working through that space thing that we were doing before Christmas. So students should be able to develop and use a model of the Earth, Sun, and Moon system to describe predictable phenomena observable on Earth, including seasons, lunar phases, and eclipses of the Sun and Moon. Okay. So it's a lot of it can be a little bit waffly, the language in these, but this is kind of the important part, okay, towards the end there. Okay, so that's essentially what we're going to do. We're going to talk about the seasons, we're going to talk about the phases of the moon, and we're going to talk about eclipses, okay? That's essentially what this chapter is about. So this is from your book. What you may already know is that there are 4 seasons. I'm hoping everybody knows that. And the rotation of the Earth on its axis causes day and night. So you may know that already, you may not, but we're going to talk about it anyway. And then what we're hoping to learn, as I said, we're hoping to learn the lunar phases, how the lunar phases and solar eclipses happen, how to develop a model of the Earth, and I would add in there that we're going to learn how seasons occur. Okay, so seasons, lunar phases, and eclipses are the big kind of learning outcomes from this chapter. Okay, so we'll just have a little look here. A lot of this we talked about in the last chapter, but there's no harm going back over it, as we did kind of have to do that last chapter a little bit quickly. So the sun is the closest star to the Earth. We learned in the last chapter that the sun is a star. And it's the closest star to Earth. It's also the center of our solar system, and the Earth rotates or revolves, or orbits is the word I'm looking for, around the sun. The temperature of the center of the sun is approximately 14 million degrees Celsius. It says here that reactions in the sun change nuclear energy. I don't know, do we remember what kind of reactions they were? They were fusion reactions. So nuclear fusion happens inside the sun, and that's where the nuclear energy comes from. It changes it into light and heat energy, and then that falls on the Earth. And so linking on then, the light energy that we get from the sun is useful because we can change it into other forms of energy. So an example that they give there is plants converting the sun into food during photosynthesis, which we haven't actually done plants in any great detail, but we did talk about photosynthesis. And one of the requirements, one of the reactants of that photosynthesis equation that you learned in first year is sunlight. Photosynthesis won't occur without sunlight. 2 things here. So we have luminous objects and non-luminous objects, okay? Luminous objects are objects that emit their own light. So like the sun is a star, it emits its own light. More, I don't know, down-to-earth examples, I suppose, would be a light bulb or a candle. And then non-luminous objects are objects that we can only see because they reflect light. Sorry, I don't know why I changed there. They reflect light from other sources. Okay, so the moon is a good example of that. So the moon doesn't give out its own light, it just reflects light from the sun. Okay, so like if you even look around the room, I'm looking here at the table I'm sitting at, or the books ahead of me, like they're not luminous, but I can see them. And the reason I can see them is because light strikes off them and then goes into my eye, and then I can see them. Okay, so I can see them because of the sunlight outside, or it's a pretty dull day, so I can see them because I have my lights turned on in my room, so the light from my light bulbs are bouncing off the dining table and bouncing up into my eyes, and that means I can see the dining table. Okay, so my dining table is a non-luminous object which I can see because light from another source bounces off it. So there are two important definitions. Shadows. So I think everybody has seen a shadow at some point. Why do they occur? The main reason why shadows occur is because light travels in straight lines. Okay, so if you look at this little diagram over here, so this is a source of light, this light bulb in red. So any of the light, sorry, let me try and draw this first. Can't multitask at the moment. So when you turn on a light bulb, it emits light in all directions like this. Okay? So the light comes out of the light bulb in all different directions. Over here, there's an object in the way. So these light rays that I'm after drawing in, see these two here? These two light rays that I'm after drawing in, they're striking the ball and they can't bend, so they can't go anywhere. So any of the light rays leaving the light bulb that strike the ball, they can't bend around it. So that light is essentially just blocked. So the first bit of light that leaves the light bulb that can actually get past it, get past the ball, is this one and this one. Do you see what I mean? So as a result, you get this area here of darkness where the light couldn't get past the ball, and because it's straight, it couldn't bend around the ball, and that's how you end up with a shadow. Okay, so it's all about light. That's why we have a shadow when we're standing there, because the light strikes us. It can't bend around us. It hits the back of us, and then we produce a shadow that's in the shape of us. Okay, so the reason shadows are produced is because light travels in straight lines. Okay, so we're going to talk about the Earth. There was a question on the Christmas exam about this, about the spinning. I don't know, was it the Earth or the Moon? Anyway, I didn't give marks for it because we hadn't talked about it, because we're only talking about it today. But you need to know these orbit times. Okay, so the Earth's axis is an imaginary line that links the North and the South Pole. Okay, so that's it. That's it there. Okay, see that one there? And that is the axis that links the North and the South Pole. And this line here, the one down through the middle, this one here, this is showing like vertical, like perfectly straight up. So the Earth is not vertical. And a lot of scientists believe that it was hit with something, like a big rock or something years ago, and it knocked it off its kind of perfect up and down, so it's tilted a little bit. Okay, now you don't need to know this number, but it's tilted approximately 20 degrees on its axis. Okay, so the North Pole isn't at the top and the South Pole at the bottom. It's actually just tilted a little bit, as you can see in the picture. So then when the Earth spins, so you have this like rotating around here. So when the Earth spins, you get this where part of the Earth is pointed towards the sun and part of the Earth is pointed away from the sun. And that's how we get our days and our nights. Ooh. Sorry, don't know what happened there. That's how we get our days and our nights. Okay, the Earth spinning, half the Earth is facing the sun and in the light, and half is facing away. Okay, and that's how we get day and night. This is important. The Earth takes 24 hours to complete one full spin. So that's your day and your night, essentially. So your daylight and your night time takes 24 hours. So the Earth takes 24 hours to complete one full spin around itself. And then you have obviously the sun appearing. It appears in the east. You don't really need to know that, but the sun appears in the east. And then you have sun for, well, depending on the time of year. Sometimes you have the sun for 14 or 15 hours. Sometimes you only have the sun for 9 hours, 8 hours. And then, so it appears in the east and it sets then in the west, and you will have the sun at the highest point at noon. Okay? It's important to remember that the sun is not moving, the earth is moving. So with regard, so you have your, if this is my sun here, which is obviously much bigger than that, and then your earth over here is rotating around so that it points towards the sun. So it's not that the sun is moving, it's that the earth is spinning and making different parts of the earth point towards the sun and different parts of the earth point away from the sun. Okay, but I did just kind of want to clarify that it's not that the sun isn't moving at all. So in the same way that the sun is the center of our solar system and all the planets orbit it, we as a solar system are doing our own orbiting. So the sun does move, but not with reference to the earth. Okay, so it's the earth spinning on its axis that gives us day and night, not the sun. Okay, so hopefully that's okay. This is the last thing I kind of want to cover today. So this is the Earth orbiting the sun, and this is how we get our seasons, okay? So first thing I suppose is that the Earth moves around the sun in an elliptical orbit. That's an important word, elliptical, okay? So it's oval. Now, not quite as sharp as a rugby ball, but that kind of idea, okay? It's an elliptical orbit. The reason it orbits is because of a gravitational pull between, so the sun is being pulled towards the earth and the earth is being pulled towards the sun. Okay, and gravity is doing that. Oh, why is that so quick? Sorry. So this is the force of gravity that is pulling them together, and that's what keeps it in that circular, not quite circular, oval orbit. Okay, also very important, the Earth moves around the sun once a year, okay, in an anti-clockwise direction, so once a year. You can see here it takes 365.25 days, and so that's 365 and a quarter days. And that's the reason why we need a leap year every 4 years to account for those quarters. Okay, so every year the Earth goes round the sun, and as it moves around, you get different parts of the Earth facing towards the sun, and as a result then you get seasons. So I thought this video was quite nice. I'm going to show you this. So we'll just watch this and then we'll come back.
Spring is here! Now, instead of building snow forts and licking icicles, we can skateboard and ride our bikes, and we don't have to worry about squeaks getting rusty in the snow. Speaking of seasons, you know we have 4 of them: spring, summer, autumn, and winter. But do you know why we have more than one season? Well, we have seasons because the Earth is tilted. Instead of standing straight up and down, it leans a little bit. Whoa, how'd that happen? A really, really long time ago, billions of years ago, scientists think something big hit the Earth. The impact was so strong that it knocked our planet over a little bit, so now Earth is tilted. And our tilted planet travels around the sun, completing one full trip all the way around every year. I mean, that's what a year is, the time it takes for the Earth to go around the sun once. And depending on where the Earth is in its journey around the sun, our exposure to sunlight changes. That means the seasons change. That's why we have 4 seasons in 1 year. Sometimes during the year, part of the Earth tilts toward the sun. Sometimes it tilts away from the sun. When the part of the planet you're on is tilted toward the sun, it's, you guessed it, summer. When it's tilted away from the sun, it's, yep, winter. And when it's in between, well, the weather's pretty much in between too. That's when we have spring and autumn. They're both a little bit warm and a little bit cool and often windy. But if the season also depends on where on Earth you happen to live, that means that not everyone experiences the same season at the same time. It can be summer in some parts of the world when it's winter in others, because those different parts of the planet are getting different amounts of sunlight. When the northern hemisphere is tilted toward the sun and it's summertime, the southern hemisphere is tilted away, so it's wintertime there. So the tiltiness of our planet explains a lot. It's why we have seasons and why it's not always winter or always summer all of the time. And it also helps us understand why different parts of the world can experience different seasons at the same time. Thanks for watching, guys. Enjoy your season, whatever it happens to be. See you next time.
Okay, so that basically explains this diagram here. Okay, so as the Earth goes on its 1 year journey around the sun, different parts of the Earth are tilted towards the sun and different parts of the Earth are tilted away from the sun with different degrees. And so as a result then, if you're tilted completely towards the sun, that would be your summer, and it's the extreme opposite then, it would be winter so when we have our summer, it's winter in the southern hemisphere and vice versa. So the moment we're in winter, the likes of Australia, it's summer. And so yeah, that's just an explanation of how the seasons work, and you need to be able to explain that. How do you end up with like summer in the northern hemisphere and winter in the southern hemisphere at the same time? Okay, this is just another diagram of the exact same thing. I just thought it was maybe a little bit more technical, so I put it in for you to have a look at. This here, it's not hugely important, but just this diagram here just to look at. I don't know if you've ever noticed it. I know I always notice it when I'm trying to drive the car in winter. The sun is much lower in winter, so it like this. It comes in at a much kind of sharper angle. So when the sun rays strike the ground in winter, they strike a much larger area, so they don't manage to heat it up. Whereas during the summer, the sun is much higher. So when it strikes the ground, it strikes, so that both of these diagrams here are supposed to represent the same amount of sun rays, like the 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So when these 5 sun rays strike the ground in June, because they're coming from such a high place, because the sun is so high in the sky, they strike like this area here. Okay, but the sun is so low in December that the same rays come in at such an angle that they strike, I mean, almost twice as wide. It could be more than that even. So that's why you don't get the same heating effect, because you have the same sun rays, but they're striking a larger area, so they don't have the same impact in terms of heating up. This bit here, this was all discussed in the previous chapter, but again, just to note, planets orbit stars. So the sun is a star, so the same way the Earth orbits sun. It's important. Moons orbit planets. So that was one of the questions on the Christmas exam as well. Something to do with the moon. It was a property of the moon or something. That's essentially what we were looking for, that the moon, like a moon will always orbit a planet. And then moon, planets and stars all rotate around their axis. Okay, so this diagram is kind of nice, right? So see here, over here we have our moon. So the moon, this arrow here represents the moon rotating itself, so it's turning, and then you have it rotating around the Earth. Same thing here, here's our Earth, and it's rotating itself. And then you also have this big rotation around the sun. And then again, you have the sun, which is a star, rotating itself. Okay, so there's a lot going on, I suppose, and it's important to note that, and you need the idea that the Earth will spin on its own axis, every day, and the Earth will orbit the Sun once a year. Okay, so we're going to move on to the lunar phases on Friday, but that's all I wanted to do today. So like I said, there's no homework. We should have homework on Friday when I've done a little bit more. It's just all the questions were kind of, they included stuff about lunar phases, so it's too hard to give specific homework on what we've just completed. But if there are any questions, please let me know in the collaboration space. And like I said, no homework, so it's really just about taking notes down and making sure you understand. Okay, I will chat to you on Friday.